Welcome back for the second example. Let's now review the HR example that you explored in class with Professor Glady. As a quick reminder, we are now the HR department of a big consulting company, and we're worried about the high number of employees leaving the firm. We want to use HR analytics to understand why employees leave and to discover the actions that we can take in order to retain our best employees. Let's turn to R. The first thing you always do is set your working directory. Once that is done, you can clean up the memory of your current R session by running this line. We are now ready to load our datasets, and we can do so using the read.table function that we already know from the SKU example. As always, let's explore our dataset using the str function. What we discover here is that our dataset contains 2,000 observations and has 6 variables. What are these variables? First, the S variable, which is numeric. As you may remember from the lectures, the S variable is the satisfaction level on a scale of 0 to 1. Then we have the LPE variable, which is also numeric, and which is the last project evaluation by a client on a scale of 0 to 1 again. Then the NP variable, which is an integer variable, and which represents the number of projects worked on by employee in the last 12 months. Then the ANH variable, which is an integer variable, and which represents the average number of hours worked in the last 12 months by the employee. The TIC variable, again, which is an integer variable, and which represents the time spent in the company in years by the employee. The last variable is the newborn variable. It will take the value 1 if the employee had a newborn within the last 12 months and 0 otherwise. Now, as we did in the SKU example, and as we will often do, let's check out some summary statistic for our variables by using the summary function. As you can see, the mean value for the satisfaction level is 0.44, and you can check out some other statistics that might be able to guide you through your analysis. Now, in order to make our variables comparable to one another, we need to normalize them. In order to do that, we will create a copy of our dataset, and we will call it test data. And in order to normalize our data sets, we use the scale function. As was explained in the lectures, the scale function subtracts the mean and divides by the standard deviation of your variable. We can now compute the distances of our data points using the dist function. And as a first argument, we've got our dataset, which is test data. As a second argument, we've got method, and we set it equal to Euclidean in quotes, don't forget the quotes, in order to compute the distances using the Euclidean method. We will store the results in D. Let's run this line of code. As we did previously, let's perform hierarchical clustering using the hclust function. We pass it the distances as a first argument and set the method equal to word point D in quotes as a second argument, and we store the result in HC word. Let's decide, like you did in class, to have 4 different clusters. As we did in the SKU example, we can assign our points to our clusters using the qtree function and creating a new variable to our original data sets called groups, in which for each observation, this is going to indicate the group to which the observation belongs. We can now run this line. In order to get a nice output table, we need to compute the mean values for each variable and for each group using the aggregate function and passing it as arguments dot, which means that we want to use all our variables, tilde, and then groups, which is the different groups that we want to have. The second argument is the data we want to perform this on. Note here that it's the original data set, so data equal data, which was the name of our original data set. And the fun argument is the function that we want to use in order to aggregate the variables. And here it's the mean function. We can now run this line. One thing that would be really nice to have is the proportion of our data that is in each cluster. To compute that, we're going to add it to ag data. We create a variable called prop temp, which computes the number of observations in each group using the s variable here, but we could have used any. And the function we aggregate with is length, which counts the number of observations. Let's run this line. Let's type prop temp in the command line to see the output. What we see here is in group 1, there are 793 observations, 626 in group 2, 476 in group 3, and 105 in group 4. We're now ready to add the proportion variable to our ag data, and we can do that by computing the ratio between the number of observations in each group, which is prop temp $s, and the total number of observations, which is 2,000 if you remember, but that you can have with some prop temp $s. Let's run this line. Now, to better organize our output table, we order the groups from the one with the largest number of observations to the one with the smallest by using the order variable. We run the line. To see our output table, we type ag data in the command line. And we can see now our ag data output table with the proportion as the last variable. Now, if you do a view ag data, you can see that one segment has 100% of employees with newborns, while the other segments have no newborn at all. This variable is a 0 or 1 outcome, and what we observe is an artifact of a binary outcome in a hierarchical clustering. Those types of variable will typically drive the results. On top of that, as discussed in the videos, we could wonder if the newborn variable is really relevant in this context. So as discussed in the videos, let's remove the newborn variable. We create a new dataset called taste data, and we set it equal to data. We include all the rows of the dataset and only column 1 to 5, which is all the columns except the newborn column. We then rerun the code used above. If you take some time and read it, you'll see that it's exactly the same thing, but we're calling it on the reduced dataset now. Assign our observations to the groups. Aggregate the values again. Compute the proportion and order the results again. Let's see the output by calling ag data. At this point, you should get the same output that what Professor Gatti showed in class. A good visualization idea is to save the output in a CSV file to work on it later in a spreadsheet tool like Microsoft Excel or Google Spreadsheet or the sort. And you can do that with the write.csv function that you can see right here. You call the dataset on it. Your second argument is the name of the file that you want to save. And our third argument here just indicates that we do not want to have the display of the row names in the output file. If for any reason with the write.csv you encounter an issue, it is most likely due to regional settings for the separator, and I recommend that you use the write.csv2 function instead. This wraps up our second example, and I will see you in the next video.